Hello everyone. Today I am going to discuss with you set theory. This is a chapter from class 11 and this is the first part of this set theory. Let us discuss our chapter by the definition of set theory. What is meaning of the term set? First, we understand what is the meaning of the term set. So, set is defined as well defined collection of distinct object. Well defined collection of distinct object. I underline first word is well defined collection and distinct object. So distinct object means different. That means all the element of the set should be different from each other. Collection, this term we use frequently in our daily life. Collection. I have good collection of songs. I have good collection of books. Now, this term is very important to define set. What is the meaning of the term well defined? Let us take one example. I am writing two statements, 5 rivers of India. And second statement I am writing as rivers of India. Now, let us make this concept very simple one. If I say 5 rivers of India and I ask 100 people, give the name of 5 rivers of India, name 5 rivers of India from across the length and breadth of the country, will you get the same answer? Somebody called Narmada, Kaveri, Saraswati, any 5 river, somebody named another 5 river. So in this case, you are not getting the same answer, unique answer. Now in spite of this, if I ask, name rivers of India, that means all rivers of India. Now, if you ask n number of people, any number of people, you will get the same answer. Clear? So, this statement will form a set. This statement will form a set where this is not a set. This is set and this is not a set. You understand? That means if a statement gives unique answer, then it is a set. Suppose if I ask you best batsman from world cricket. Best batsman from world cricket. Now, or I say best 3 batsmen from world cricket. Now, if you ask this question to 10 people, 20 people, 100 people, will you get the same answer? Your answer is no. All have, because why you are not getting the same answer? Because you use a word best. Best is not measurable. Once you can't measure a quantity, it is not a quantitative thing, it is a qualitative thing. So best for you can be a batsman who can score a century, or for you a batsman who can make some useful contribution of 40-50 runs at the beginning of the innings might be best, or you might be a good finisher of the game will be the best for you. So see, these things are not defined, not well defined. So it will not form a set. Now if I say vowels of English alphabet, vowels of English alphabet, same thing, A, E, I, O, U, A, E, I, O, U. You ask 100 people, you will get the same answer. So this will form a set. So well defined means if you ask the question from 100 people, 200 people, n number of people, ask yourself, am I going to get the same answer, unique answer? If your answer is yes, then it will be a set. Then it will be a. Now, if I take some example, which you can write or which you can listen carefully, the collection of the days in a week, the collection of the days in a week, beginning with the letter S, beginning with the letter S, will it form a set? Now if you ask anyone, you will get the same answer as Saturday and Sunday. Clear? So it will form a set. So in the first part we define what is set. So set is defined as well-defined collection of distinct object. Well-defined collection of distinct object. For your understanding, keep it in mind that if a statement is given to you, judge yourself. Will this statement lead to me a unique answer, or I may get different answer? If your answer is yes, I am going to get a unique answer, then it is a set. Clear? Let us take some example to understand, or how we can define set, or which are not a set. So we define set. Let us take some example to identify whether this statement will make a set or not. The first statement is the collection of all the months of a year beginning with the letter J. Collection of all the month of a year beginning with the letter J. Now all the month, there is no such criteria. Beginning with the letter J, that is January, June and July. Now I give you a mantra. Ask yourself, if you ask this statement to n number of people, will you getting the same response or different response? Your answer is same response. That means it will form a set. So now how you will justify your answer? So you write, since the month which start or begin with the letter J are January, June and July. So it is a well defined, so it forms a set. The collection of 10 most talented writer of India. 10 most talented. What is the definition of talent? It is an adjective. So, any adjective, if a statement contains any adjective, it will not going to form a set. Because there is no such criteria. Talented. You might come across n number of friends. Your choices of writers are different. Somebody like someone, somebody like some other one. So, talented is not a well-defined term. Clear? And you remember one thing. If a statement contains an adjective, this will not going to form a set. So, it is not going a set. A team of 11 best cricket batsmen. Best. Again an adjective. So, not a set. The collection of all natural numbers less than 100. The collection of all natural numbers. The collection of all natural numbers less than 100. Less than 100. Clearly defined, it will contain all the numbers starting from 1 till 99. Less than 100. Clearly mentioned, less than 100. So, it is a set. The statement will form a set. The collection of all boys, there is no such criteria which makes it not well defined. The collection of all boys in your class. A collection of most dangerous. Somebody consider lizard as dangerous and love snakes. Somebody likes some small insect as dangerous. So, most dangerous. Again, it is an adjective. So, it will not form a set. Not a set. So, whatever book you are following, you will see the first question of your book is like this. You need to identify which of the following are set and you need to justify. So now you go through my video till this part. If you understand, open the exercise, try to solve, match with your answer. If you are getting some confusing answer, drop your comment in my comment box. I will take your question in the next week. Moving into the next article, I am going to explain you how we are going to represent a set. That is, what is the description or representation of a set. Now, a set is represented into these two forms. One is called set builder form and another is roster form. Set builder form and second one is roster form. So what is the meaning of set builder form? Builder, generally we use the term which build something. So in set builder form, a mathematical statement will represent a set. A mathematical statement will represent a set. So we writing mathematical statement represent a set. For example, if I say A set is represented within the curly bracket, so we put the curly bracket. A is the set of, suppose if we say vowels of English alphabet. A is the set of vowels of English alphabet. So this is a statement which represents a set. Now roster form means here the element itself represents the set. Here element or elements itself represent the set. Represent the set. Corresponding to A, if I write A is equal to A E I O U. A E I O U. Now see, whether I am telling or writing vowels of English alphabet or I am writing A I O U, it means the same set. But in one case, any statement is representing a set. In another case, element itself are representing the set within the curly bracket. So whenever you are writing a set, you need to write it capital letter, generally represent a set until and unless stated otherwise, and you need to give the curly bracket and you need to write the element A, E, I, O, U. These are called element of the set or member of the set. So if I write A, E, I, O, U here, so this will represent element or member of set. Clear? Suppose if you take another example, B is the set of square of natural number less than equal to 5. Set B is the square of natural number less than equal to 5. That means it contains a square of natural number of less than equal to 5. So B 1 is the square of natural number, 1 is a square of itself, then 4 it is the square of 2 less than 5. Now see, B and this elements are same, both sets are same, but representation is different. So set builder form means a mathematical statement representing a set, or if an element represents a set, then we called it as a roster form. We'll take some example to explain you further to make the concept crystal clear to you. Now, we explain you what is set builder form and roster form. Now let us discuss some problem. Write the following sets in roster form. Obviously, it is a mathematical statement which represents the set. So it is given in the set builder form, and we need to write this in a roster form. Now see the statement, how you are going to pronounce it, how you are going to read it. You need to read as A is the set of A is the set of. So once you pronounce or read as A is the set of, so it is means A is equal to curly bracket start. All those element X, all those element X, all those elements X, this is the sign of such that, this is a sign of such that all those elements X such that X is an integer, and then you need to write the statement here. Clear? So how you read a statement, that also important to know. Now you can pause the video and read this statement so that this part will be clear to you. C is the set of. I told C is the set of. Once you tell me, so how I am going to write? C is equal to curly bracket start. All those element X such that X is a 2-digit natural number such that sum of its digit is 8. So we learn how we are going to read a set given in the set builder form. Now you need to write in a roster form. The question is a set builder form, a set is given in set builder form, you need to write it in a roster form. So we write A is equal to, or A is the set of, better to A is the set of. Now we start the curly bracket to write the element, because in roster form element represent the set. X is an integer, X minus 3 is less than equal to X less than 7. So minus 3, minus 2, minus 1, integer, so 0, 1, 2, 3, 4, 5, 6. Less than 7, so will not include 7. Am I clear to everyone? Moving into the next part. X is a 2-digit natural number such that sum of its digit is 8. Sum of its digit is 8. So we write C is the set of all those elements. Now list out the element. 2-digit number and sum of the digit. Sum of the digit means suppose 11. 11 is a 2-digit number. Sum is 1 plus 1, 2. Sum is equal to 2. 12. Sum is equal to 3. So we need to list down all the two-digit number whose sum is 8. Now don't search for the element randomly. Forget about 1 to 9. From 11 to 20, you will get 17. Once you get 17, leave some place and write 71 also. Next is 20 to 30. 26 is the number whose sum of the digit is 8. Write 62. 30 to 40. 35. So write 53 also. Now 40 to 50. See, one gap is there. 44. Now moving into, so this will give 50 to 60, 60 to 70, 70 to 79. Now two digit number is 80. Sum of the digit is 8. Now will you get any element further? No, because 81 minimum is 9. 82 10, 83 11. So minimum is 8. So all the elements are 17, 26, 35, 44, 53, 62, 71 and 80. Clear? Moving into the next question. Write the following set in set builder form. In the last question we discussed, if a set builder form is given, how you are going to write in a roster form. Now here elements of the set are given and we need to write in a set builder form. To write in a set builder form, you need to analyze the element, how the elements are connected by a well-defined rule. 2, 4, 8, 16, 32. All are 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. So we write this set contains all those element x such that x is equal to 2 to the power n, such that x is equal to 2 to the power n, where n belongs to capital N. This is a sign of belongs to. That means when an element is there where n belongs to capital N and n is less than equal to 5. Am I clear to everyone? Again I am repeating, all the elements you are seeing, they are 2 to the power something, 2 to the power n. If you substitute n is equal to 1, you will get this element 2, 3, 4 and 5. So we write where n belongs to n. Why it is necessary to write n belongs to n? Because if you consider R, if you are not written anything, that means it is a set of real number. The set of real number contain all the number, fraction and every number. So we write n belongs to n and small n is less than equal to 5. Look at this example, 1, 4, 9, 16 and 100. 1 square, 2 square, 3 square, 4 square, so on and 10 square. So that means it is a square of natural number. It is a square of natural number. So we write x such that it is a set of all those elements x such that x is equal to n square. Now n will take value from 1 to 10. So you can write n belongs to n and 1 less than equal to n less than equal to 10. There are many representation. You can write it as, if you are not comfortable with this format, you can also write it as, you give the curly bracket and write all the elements are power of 2 where power is less than equal to 5. This way also you can write it is a square of first 10 natural number. You can write this square of first 10 natural number. So there are many ways you can represent it. It is not the way I am writing here. You can write it, you need to analyze the element and you can write it in way you are finding the concept clear. Clear? So my suggestion is pause the video a little bit, open your exercise, try 1 or 2 sums. Each time you are moving from one concept to another concept, you need to go through how much I will learn. Now, if you practice 1 or 2 sums, match with your answer. If you are getting, that means we are in a learning phase. We are learning something, you are understanding. Make it an interactive session between you and me, so that this learning teaching process will go on simultaneously. Now, let us move into the next article. What is equal set and what is equivalent set? So, our next point of discussion is equal set and equivalent set. Now, before we discuss equal set and equivalent set, let us discuss the cardinal number. What do you mean by cardinal number? Cardinal number represent number of element in the set. Suppose a set contains 4 elements. So the cardinal number is equal to 4. So cardinal number represent, it is the number of elements in the set, and it is represented by n of A or n of that particular set. Suppose I am taking here set as A, so you can write it as n of A is equal to cardinal number. Clear? Now, suppose if I am writing set A is equal to 1, 1 by 2, 1 by 3, 1 by 4. So, corresponding to this, cardinal number is equal to 4. Cardinal number is equal to 4. Now, moving into our main topic, equal set and equivalent set. Listen carefully. If two sets have same cardinal number, then they are said to be equivalent set. If two sets have same cardinal number, so set A and set B are said to be equivalent if n of A is equal to n of B. That does not necessarily mean that they have the same element. Suppose if I take a set A as 1, 2, 3, 4, 5 and B as A, E, I, O, U. Now see, set A, 5 elements, so cardinal number of A is 5. Set B contains 5 elements, A, E, I, O, U, so cardinal number of B is 5. See, elements are different. Elements are different, but the total number of elements are equal. So they are said to be equivalent. And what about equal set? A and B are said to be equal if number 1, NA is equal to NB. That means those two sets must have the same cardinal number, and second, each element should be equal. Each element or elements of the set are equal. That means if we consider a set A as capital A, capital B, capital C and capital D, or you can write, since these two might confuse you, I am writing small a, capital B, capital C, capital D, B as C, D, B and small a. Sequencing of the element might differ. Don't bother about that. Check. First thing, 1, 2, 3, 4, 1, 2, 3, 4. First condition satisfied. That means they have the same cardinal number. Small a, capital B, small capital C, capital D, capital D. All the elements are same. They are said to be equal. So, recap these two concepts in a second. Cardinal number, only the cardinal number same, equivalent set. Two sets, they have the same cardinal number, only equivalent. Cardinal number same, element of the set are same or equal, they are said to be equal set. Now, let us discuss types of set. So now there are different sets. We discuss all the kind of set one by one. First set is empty set. First set is called as an empty set, or it is also known as the void set, or you may also call it as a null set. Empty set, void set or null set. The name itself represents it is vacant. That means if number of element in the set is equal to 0, if the number of element in the set is equal to 0, then they are called said to be empty set, void set or null set. So if the number of element in the set is equal to 0, that means absence of element, absence of any element. So they are said to be a null set. It is represented by phi or curly bracket, but there is no element is there. Clear? Now there are few things you need to keep in mind. Sometimes the question is it an empty set or it is a null set? Answer will be no. Because 0 is one of the element. No, as 0 is one of the element present in the set. Am I clear? I'm just putting by mistake dot, then also it is no, because now this dot becomes an element of the set. Clear? Or don't write, okay, I'm writing null set. No, 5 will become the element of the set. So once you are representing a null set, it is only 5 or only curly bracket without anything. This needs to be very clear in your mind. Now, if you consider an example of an empty set, from set A is the set of all those element x such that x belongs to n, 5 less than x less than 6. That means you need to find a natural number between 5 and 6. Will you get any element? No. Then it is an example of empty set. Am I clear to everyone? Now, the next set I am going to discuss with you is Singleton set. Singleton set. Name itself represents the number of elements in the set is equal to 1. So we write number of element in the set is equal to 1. If a set contains only one element, then the set is called to be Singleton set. Clear? For example, A is the set of all those element x such that x belongs to n, 5 less than x less than 7. That means we have set A contains a natural number between 5 and 7. So between 5 and 7, 6 is the only element. So if I write this as a roster form, so I write A is equal to, A is a set which contains the element 6. Only one element, so it is an example of Singleton set. Am I clear to everyone? Now, we continue our discussion. Moving into the next set is called finite set and infinite set. So we will discuss finite set and infinite set. What is finite set? If a set contains countable number of element, that means number of element in the set is countable or finite, then we called it as a finite set, or else we called it as an infinite set. So if the number of elements in the set is finite or countable. We called it as a finite set. Number of element in the set is infinite. Suppose if we consider set of English alphabet, it is an example of finite set because it contains 26 elements. Infinite set, n, that means set of natural number. Z, set of integers. R, set of real numbers. All are examples of infinite set because it contains infinite number of elements. So, finite set, if element is countable, then we call it as a finite set, or otherwise we called it as an infinite set. That means if the number of element is uncountable, you can also write this as uncountable. In the next episode, we are going to discuss subsets, universal set, power set, and Venn diagram. Till now, practice the sums from your exercise. If you like our initiative, click on the like button, share it, and subscribe it. Thank you.